Okay, so I created a class and got a free 30-day classroom trial with IXL. I'll speak with Miss Hirsch about what to do for the future, but that gets us through our course anyway. So it appears to be allowing me to do it, and I guess I could somehow add you guys to it so that you could use it more, but I'll have to ask Miss Hirsch how to do that because it lets me create a roster and I put the names, but then I guess I need to put your emails in and everything. Anyway, I'll deal with that later because right now we need to continue factoring. So the next thing to talk about is special quadratics. So there are a couple of different kind of types of quadratics that you ought to hopefully recognize um, immediately. One of them is the difference of squares. So come on, pen. There we go. Um, if hopefully we remember how to multiply, maybe I should have stopped and multiplied binomials first. So foiling, right? So if I have, for example, x minus 3 times x minus 7, then I FOIL. Because what I'm doing is distributing twice, really. This is x times x minus 7 and negative 3 times x minus 7. So that's x squared minus 7x minus 3x plus 21. Okay, so there's the first. Outside, inside, last. So it's just a double distribution. But this is, everybody memorizes this is FOIL, but this is why it's doing it. First you distribute this, then you distribute the pieces, these two pieces, and you get FOIL. So what happens if I have x minus something and x plus the same thing? Well, my first is x squared. My outside is plus 2x and my inside is minus 2x. So if these are opposites and these are the same, then these cancel. So that's why this ends up being a kind of special situation. And then we have minus 4 on the outside. So I have x squared minus 2 squared, and that is the result of this minus 2 plus 2. So if you see something like x squared minus 9, square, square, and there's no middle x, notice. So no like this minus 10x part, not there. So we have x minus 3x plus 3. And this is one of those that you just want to recognize straight away. I don't really understand why that disappears when I'm on pen, but okay. So if you see x squared minus 25, x minus 5, x plus 5. If you see 25 minus x squared, you can factor out the negative 1 and make it this, or you can just go 5 minus x, 5 plus x. If you see a squared minus 4b squared, well, this is 2b squared. So a minus 2b, a plus 2b. 2b or not 2b. Anyway, so this is difference of squares. Another thing that we fancy as special is instead of the difference of squares, the square of a binomial. So if I have, say, x plus 3 squared, that's x plus 3, x plus 3, x squared. So first, outside, inside, last. First, outside is 3x. Inside is also 3x because those are the same. And the last is 9, which is the square of 3. So because the 3 is on the outside and the inside pairs, it happens twice. So for this case, we have x squared plus 6x plus 9. But what's always going to happen is this is going to be double the number, and this is going to be the number squared. So if you ever see a quadratic where the last number is a square and the middle number is double that, then it's a perfect square trinomial, which is to say it's a binomial square. If this was x minus 3 squared, because negative 3 all squared is still positive 9, you'd get x squared twice negative 3, so 9 minus 6, but still plus 9. Okay, so if you see, for example, x squared minus 8x plus 16, half of this is negative 4, and that squared is 16. So this is a perfect square trinomial. X squared plus 12x plus 36. Half of this is 6, and that squared is 36. If you see x squared plus 10x minus 25, half of this is 5, and that squared is positive 25. So this one is not a perfect square trinomial. So you have to first look at this. If this isn't even, and this is a whole number, then it's not one. If it's even, half it, square it, and see if that's the last number. If so, then you're good. Okay, so let me go back to the ISL now. Got all this stuff happening with my Camtasia down there. Okay, so h squared minus 6h plus 9. So because it has that middle h, it's not the difference of squares. And you take half of negative 6, and really you can just forget the sign, right? Because when you're checking to see if it's a perfect square trinomial, because the sign's going to get squared away anyway. So let's just say, okay, 3, half the 6 is 3, and that squared is 9. So this is, in fact, a perfect square trinomial. So h minus 3, so it's the half of the middle is the second part, always. Let me see if I can just put squared. Good, okay. This one does not have the middle f, so the thing to consider is, are the two outside ones squares, and is this a minus? Because if that's not a minus, then it's a complex solution, not a real number solution, a complex number, imaginary in fact, which is not what we're looking at right this minute. But if this was plus, then you would stick an I on the end of the last two. Okay, so anyway, let's look at this now. The square root of 16f squared is the square root of 16 times the square root of f squared. And then this one, the square root is 5. So we're going to have the square root minus the square root times the square root plus the square root. Now, because the reason that these work is that they cancel out that middle term, because the plus and minus cancel out the O and the I in FOIL. Even no matter what I put here, I could put IJKLM, it doesn't matter, and it would still cancel out, right? So that would not affect the middle. It would not affect the first part, because the first part is just from the 4 F's. So if I put an I right here and an I right here, it would still drop the middle out, and 16f squared would still be the first. But what would happen with this is 5i times 5i is 25i squared, which is negative 25. So that would change this to a plus. So if this was 16f squared plus 25, it's still the difference of squares as long as you allow I, but of course it's not. So there's that one. This one doesn't have the middle part, so we don't consider a perfect square trinomial. So square root of 9 times the square root of z squared minus the square root of 1 and difference of squares. This one has the middle, so we need to consider a perfect square trinomial. But we have this 25 issue as well. So let's think about it. This one's a little more difficult, and I'm not sure why it came up so early here. But if this was going to be a perfect square trinomial, this part has to be the first bit squared. So this would still have to be 5z, just like if it was 25z squared minus 9, right? So if we're going to try it, it's going to be 5z. In this particular case, I know that it's got to be one of those because I'm actually in the special cases practice of IXL, but which I guess I'll leave open and link for you guys. But so that would have to be 5z. And the last bit would have to be 3 because of the 9. The middle would have to be minus because of that minus. Because the minus 3 squared makes 9, but the middle part would have to be negative. So what we need to check is, if I square this, does this equal this? So what I need to know is minus 3 times 5z, which is outside here, minus 3 times 5z, plus minus 3 times 5z, because that's also inside, does this equal negative 30z? So this is negative 15z, and this is negative 15z, and sure enough, that equals negative 30z. Okay, this one's a little simpler, and because there's just a 1 right there, all we have to do, there's the middle r, so it's not a difference of squares, so all we have to do is look at the negative 10, take half of 10, 5, square it, 25. So this one is a perfect square trinomial, so we take r and minus 5. Okay, so half of 12 is 6. Square it, you get 36. And it's minus 6 because of the minus 12. Half of that is negative 6. This one can't be a perfect square trinomial, but it might be a difference of squares. So we look at it and we say, what's the square root of 49? 7. What's the square root of j squared? J. Square root of 25 is 5. And then we do the opposite. It's actually called conjugate in a way, but okay. Square, this doesn't have the middle, so difference of squares maybe. Square root of 64, square root of x, square root of 5, and then do the opposite. And if you were just doing this like out in the world, you know, instead of in the special cases practice, the fact that it has something x squared minus something else indicates right away that you should consider this as a possibility. It's just two terms that should strike your brain to go, oh, wait. Okay. Square root of 49, square root of w squared, square root of 1, and then opposite. And by the way, if this was like w to the 4th, the square root of that is w squared. So you'd have 7w squared minus 1, 7w plus 1. And then this one would actually be another difference of squares, but you'd have a root 7, so we're probably not going to have that until next year. Square root of 16, square root of p squared, square root of 49. And then opposite. Okay, so this one has all three pieces, so we check for a perfect square trinomial. Half of 2 is 1. You square that, you get 1. So this is f plus 1 because it's plus 2, so half of it's plus 1. squared. I almost feel like we've already done this one. Okay, so I'm going to, I guess I'll do 2 more of these and call them done. 8n minus 3, 8n plus 3. Oh, I was really hoping this was going to be a trinomial. Okay, maybe one more. So square root of 121 is 11. Oh my goodness, I missed a parentheses. That would have been bad news. And opposite. Yay, okay. So this one, if it's going to be a perfect square, there's going to be 5h. So that's the square root of 25h squared. There's going to be a minus because this is a minus, and an 8 because of the 64. And that's going to be squared, if that's correct. So what would make you think to try this if you were just out factoring generally is that 25h squared is a square and 64 is a square. So that's what makes you kind of look for it. So we would have minus 8 times 5h twice. So that's minus 40h twice, which is what we have. Hoping for one more simple trinomial. And I'm not going to get one. So I guess I'll try this one time. It's minus because the minus there. I now, as you saw, have a email from Miss Hirsch about the IXL account, but now I've made one, so that's fine. Okay, so minus 11 times 9 is minus 99, I mean, and twice that is minus 198. Okay, they're not giving us any more simple ones, so hopefully this is pretty clear for this part, and I guess I was going to do one gigantic video, but I guess I'm doing it in pieces now, which is probably better as far as inserting it into the thing. So what I'm going to do is charge my computer and eat lunch and come back. So hopefully these will be uploaded by the time I do that.